Hello students, so we have reached the end topic of the fourth unit, that is chi-square test here. So till now we have discussed about the quantitative data, means the data which can be measured in any of the physical units. But when the data is not measured in any of the physical units, then that data is known as the qualitative data here. So to test the hypothesis regarding the qualitative data, we use the chi-square test for attributes and goodness of fit here. So this chi-square test is also partially based on the normal distribution, which carries the values from 0 to infinity here. So this chi-square test is basically carried on the purpose to test the difference between the observed and expected frequencies here. So in this class today, we are going to discuss about the chi-square test for goodness of fit, chi-square test with equal and unequal frequencies, and chi-square test for independence of attributes. So here you can see the examples of gems which are manufactured in the color of here red, green, yellow and blue, right? So to test whether the manufactured products are completely based on the binomial distribution, means the defectiveness of a product is completely checked or not, that we can do using this chi-square test for goodness of fit here. So in the chi-square test for goodness of fit, the null hypothesis is given as here: there is no significant difference between the observed and expected frequencies. Against the alternative hypothesis, there is a significant difference between the observed and expected frequencies here. So we have to remember one point, that in the chi-square test for qualitative data, always the alternative hypothesis is two-tiled only. Then under the null hypothesis, the test statistic is given as summation of observed minus expected frequencies whole square by expected follows a chi-square distribution with n minus L minus k minus p, where n represents the number of degrees, means number of observations, L represents the linear restriction, and we have only one linear restriction, that is sum of the observed frequencies must be approximately equal to the sum of the expected frequencies. So always L value is equal to 1, and k represents the number of parameters estimated. So if we are using the binomial distribution here, the parameter for binomial is p. So we have to estimate the parameter p for the following given data here. So in that case here, k value is equal to 1. And coming to the Poisson distribution, there also the parameter of Poisson distribution is lambda, which is also we have to estimate using the given data here. So in the case of Poisson distribution also, k value is equal to 1. Then next comes the last one, p, which represents the number of degrees of freedom lost due to pooling here. That means whatever the expected frequencies we obtain using either binomial or Poisson here, all the expected frequencies must be exactly equal to 5 or greater than 5 here. If any of the expected frequency is less than 5, then we have to add that particular frequency with the above or below frequency. So whatever we are adding with the above or below frequency here, that is called pooling. So finally here, p value represents the number of expected frequencies less than 5. So the tabulated value of chi-square is obtained at n minus L minus k minus p degrees of freedom here. Then EI is the expected frequency, which is obtained either using binomial or Poisson distribution. Then if chi-square calculated is less than chi-square tabulated, then the null hypothesis H0 is accepted. But if chi-square calculated is greater than chi-square tabulated, the null hypothesis H0 is rejected here. Then next comes the chi-square test with equal and unequal frequencies. So to test the distribution of the numbers in a telephone directory or in a telephone number, whether the numbers, all the digits are equally distributed or not, so for that we can use the chi-square test with equal frequencies here. So here you can see the phone number example here. So all the digits are completely distributed or not, or equally distributed or not, that we can test using this chi-square test here. So for that, the null hypothesis is given by here: there is no significant difference between the observed and expected frequencies, or the frequencies are equally distributed, we can frame. Then again, as the alternative hypothesis, of course it is two-tiled, that means there is a significant difference or all the digits are not equally distributed here. Then the test statistic is given as same as that as the goodness of fit, that is observed minus expected frequency whole square by expected follows a chi-square with n minus 1. So here the tabulated value is obtained at n minus 1, where n represents the number of observations given to us. But here the expected frequency is given by the formula sum of all the observed frequencies by number of observations, because here the test itself represents the test for equal frequencies here. So the expected frequency must be equal for all the observed frequencies. But when in the case of unequal frequencies, here we have a different ratio for finding the unequal expected frequencies. So using that ratio we have to find the expected frequencies. So how to find the expected frequencies for the given ratio, that we will discuss while doing the problems. Then we have to obtain the chi-square tabulated at n minus 1 degrees. Then if chi-square calculated is less than chi-square tabulated, H0 is accepted, otherwise H0 is rejected. So the last one is the chi-square test for independence of attributes. So where we can apply this independence of attributes. So here you can see the example, a manager is discussing with the sales executive. So here the sale of a product is based on the performance of the salesman, how well the salesman is representing the product, right? That representation of the, means the sale of the product is based on the representation of the product here. So just the sales and the representation of the salesman are good associated or not. So to test that we use the chi-square test for independence of attribute. Not only this one, here also we can test the education of a child and the economic conditions. So is the education of a child is completely based on the economic conditions of their home. So that we can test using the chi-square test for independence of attributes. So for that the null hypothesis is given by the two attributes are independent, and against the alternative hypothesis the two attributes are not independent here. So this test is particularly carried based on two attributes A and B, where A is classified into two attributes or three attributes like R attributes, and B is also classified into some two classes, three classes, or R number of classes here. Then the chi-square test statistic is given by the formula double summation Oij minus Eij whole square by Eij follows a chi-square distribution with R minus 1 into S minus 1, where R represents the number of rows and S represents the number of columns. So what is this R and S here? For example, you just consider the two attributes A and B, where A is represented into two classes A1, A2, and B is represented into two classes as B1, B2 here. Then A, B, C, D are known as the observed frequencies. For these observed frequencies, we have to obtain the expected frequency using the formula Ai into Bj by capital N, where N represents the total frequency, which must be equal to the A plus B plus C plus D here. Okay, that means the rows total and the columns total must be equal. Then expected frequency is here just the first row total into first column total by expected frequency for the first one. Then first row total, second column total by total frequency. That means Eij is equal to Ai into Bj by capital 1. So capital N here. In that manner we have to obtain the expected frequencies. Then the tabulated value is obtained at R minus 1 into S minus 1 degrees for the corresponding level of significance. Then again the same conclusion, if chi-square calculated is less than or equal to chi-square tabulated here, the null hypothesis H0 is accepted. And if chi-square calculated is greater than chi-square tabulated, then the null hypothesis H0 is rejected here. So in all these three tests, we have to observe one thing, that the calculated value cannot be negative. It is always positive, because the test statistic we have a formula square, observed minus expected whole square. So always the chi-square value is positive only. So there is no question of negative calculated value here. So this is about the chi-square test for the goodness of fit, expected frequencies means the independence of attributes, and equal and unequal frequencies. Now let us see the problems on chi-square test for independence of attributes.